This conference will now be recorded.
Sir, I understand linked
Yeah.
list now, I think, but sir, we never went over the multiplication of two matrices using arrays. I remembered while I was reviewing linked list.
Okay, okay. Uh, using linked list, you mean to say
Oh, no, using,
multiplication of two arrays?
sorry, sir.
Yeah, multiplication of two arrays, right?
Yes, sir.
Yeah,
Multiplication
yeah,
of matrices using arrays. Yeah.
we discussed it, right? We got some issue there. I forgot that one.
Yeah, it's okay. We can go over it
Yeah,
next class. You don't have to go over it
yeah.
today.
Tomorrow we do it. Tomorrow we do that one.
No
I'll make a
problem.
note of it immediately, and tomorrow we do that multiplication of two matrices.
No problem,
Yeah,
sir.
yeah. Yeah.
Sir,
Anything
you
left out?
do you teach C++?
No, no, Karthik. Long back I've taken.
Okay, sir. No
Even
problem.
C language and C++, maximum I won't do since you have come through reference, no? So that I'm taking for you actually. So
Okay,
when
no
I
problem.
said okay to you, then immediately Teja and Rutvik also joined. That's the background. So actually, generally I won't take C classes. I take more of Java classes.
Okay, sir. No problem. Don't worry.
Java classes I'll be
Because
having
that
10
I
timetable.
have. Yeah, wait, sir. Give me 1 second.
Yeah.
Hello. Yes, sir.
Yeah. Yes.
Uh,
Yes.
oh, nothing, sir. Because like I was trying my headphones because I can't
Okay.
usually hear you because my laptop speakers are very bad, but the headphones aren't working. Okay, no problem.
Okay.
But no, sir. I just wanted C++ because it's part of my next semester. That's why.
Oh, 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 oh. Okay. Okay.
But I might just
So,
do Java because my sister told me that Java and C++ are similar. So I will see.
right. Right.
Study
Yeah,
side.
when you are doing Java, then there is no requirement of C++ in the industry actually. So you
Oh,
are using more of Java only, Java coding. Okay.
yeah.
However, I'm having some notes of C++ which I've prepared. I'll share that one to you. You can
Oh,
use it.
so that will be that will be very helpful, sir. If you can do that, I'll
Yeah,
be
notes
very
is it,
happy.
but no recording. I did not take any batch of C++ up to now online, but I made a notes where I was dealing with some of the engineering students. I prepared some text notes, so I'll share
Yes.
that one. Even C also I need to share it. I
Okay.
missed out
Thank
that. Also C data structures, everything. I'll sit tomorrow and I'll work on your documents only and I'll send it to you.
thank you
And
so much.
tomorrow we go with searching and sorting and this matrix multiplication. We do that one tomorrow.
Okay.
Okay,
Thank you.
with that we close it tomorrow. Then
Thank
when your requirement comes to Java, again you can attend.
Okay, sir. Thank you so much.
Java, no issues at all. I'll be having something around every day, 8 to 9 batches will be going for Java only for me.
Yes, sir. Sir, I think I'll learn Java at the end of the semester as like an extra feather for my cap. But like for this
Oh,
semester, to know C++. But I will be learning Java soon though because I know it's
okay,
important in these days.
right. Outside, Java is more important now.
Yes, sir. I know. But like my course is teaching C++ for some reason. So for
Right,
now, I
right.
want
You
to
concentrate on that. You concentrate on that first. After
yeah.
completion of that only, think of Java. Okay?
I will
Because
be
too
no
many things
experimenting
is
doing
going to
Java
begin.
for sure because my sister said that Java is very important too. So I will be
Right.
going over Java too. Yeah.
Today, let us start off with one more trace concept.
Yes, sir.
Okay? So, uh, when you go for linked list, arrays and linked list comes under linear data structures. Linear means continuous, like a sequence of elements.
Yes, sir.
Okay, after one element, first if I say 10, next element is 20, 20, after that 30, like that. But trees are non-linear data structures. Very, very important Viva question actually. What are linear and non-linear? Linear means arrays and linked list are linear. Then trees comes under non-linear. There are
Yes.
some more linear like stacks and queues also, but it is not there for you. But however, I'll share the notes of that also. So if whenever you get some time, you can go through that.
Okay.
So trees are non-linear data structures consisting of nodes. Consisting of what? Nodes. Let me show with a diagram. Here, it's a node. This is one node. And one node, this is what we call the first node, what we call it as the root node. And
Yes,
it
sir.
goes with the left node. It goes with the left node. Again, one more child node. These are called as child nodes. The
Yes.
subnodes are called child nodes. Again, for this, again, we are having two subnodes.
Yes, sir.
Okay. So for this also, again, two subnodes. For this also, one more subnode.
One more, sir. Yes, sir.
Okay. And the last node, last node, which is not having any children, the last node, which is not having any children, they are called as what? Leaf nodes. They are called as leaf nodes. Okay.
So it's like the null value in linked list. So the last value without any further
Yes.
value,
All right.
right?
Right. Right. Similar to that.
Yes, sir.
Similar to that. Okay. So the last nodes we call it as the leaf nodes. See the
Yes.
definition. They'll ask this type of definitions only. Elaborate about trees means you should write all these things.
Yes,
Okay.
sir.
So root node. What is root node? Root node is the starting node of a tree, which is the base for each and every other. Which is the base for each and every other nodes of the tree. That is your root node. Okay. Then siblings. What are siblings? The nodes which have the same parent are called as siblings. So here in this case, these three are considered as siblings. Got it?
Okay.
Which is having the same parent. These two
Because
are considered as siblings.
yes, sir.
These two are considered as siblings. Got it?
Okay. Yes, sir.
Which has the same parent. So, then next one, leaf nodes. What are leaf nodes? The nodes which are not having any children. Which
Yes.
are not having any children.
Children.
Then order of a node. The number of children. The number of children present to the node. So what
Yes.
is the order of this first node? The root node?
3, sir.
3. So what is the order of this node? This one. Let me highlight. What is the order of this node? 1. Right? Clear? So
Mm-hmm.
the number of children present in a node, that is the meaning of order of a node. Then
Yes,
one
sir.
more good definition. Height of a tree. The maximum possible length from root node to the leaf node. So in this example, what is the height of the tree?
Root node to the leaf node. So 1, 2, 3, 4. 4, sir.
No, we have to say 3. 1, 2, 3.
Oh, okay. It's the amount of links. I was counting the amount of circles.
Links.
Okay.
No, links. That link only we call height of the tree.
Okay,
So
sir.
1, 2, and 3, the maximum possible. So to this leaf node only 2 possibilities. To this leaf node only 1. To this
1.
leaf node only 2.
And then
Okay,
2.
but for this we are having 3. So the
Got
maximum length between your root node and the leaf node, whichever is the maximum, that is called as the height of the tree. So these
got
definitions only they'll ask for your exams. So even they ask you to write something about trees, you have to write all these words.
Yes, sir. Got it.
Okay. Binary tree is more important. What is binary tree? Is the trees in which every node contains at most 2 children only.
Yes.
Maximum 2 children only. So we should not have more than 2 children. At most
Got
2
it.
children.
Oh,
Then
because
we call
binary
it as
you only have
binary.
0 and 1, right?
Right.
So you
Only
can't.
2 children. Like
Got it.
example, we take binary tree. Here, you're having a binary tree, a node. Here also we call node divided into 3 parts here. Middle one is data, left node and right node. Left contains address of the left node, right contains address of the right node. See here. See when you take the element here 100, see here, the element value is 20. The element value is what here? 20.
Yes,
Then
sir.
left node contains address of the left side node. So what is address of this node here? 200. So what it stores here? That is. Right node contains the address of the right node. Address of the right node.
Yes, sir.
Okay. Then, so for this 300, if there are no children, then left and right will be null. And see
Oh,
for 15, again we are having a right children. So again we'll take the address of the right children.
right one.
Whose
Then
value
that's
is
400. Okay, got
if
it.
they are not having any left children, we have to assign with null here.
Null.
Null.
Got it.
Got it? How
Yes, sir.
binary tree looks?
Yes, sir.
Okay.
Sir, I was wondering while I was doing linked list and like now I'm looking at this. What is the application of these? Like when do we use all of this stuff in C?
See, linked list, all these things, linked list, trace, all these things are used for operating systems. When you are
Oh,
creating operating systems, no, there we use this. Search
oh,
operation trees are mainly used for search operation.
oh, I
Linked
see.
list are used to store your files on your hard disk. Let me
Oh,
take the real example of linked list.
okay,
So
sir.
you are having a understand carefully. Let me take the real example of linked list where we use. So this is my hard disk.
Yes, sir.
This is my hard disk. So when you take your hard disk is divided into some blocks, right?
Yes, sir.
Hard disk will be divided into some blocks.
Yes, sir.
To store your data, we'll have blocks. Okay. Once you have blocks, okay. So the addresses, let us suppose that the addresses are like, let me start with 0, 0, 1, 2, 3, 4, 5, 6. These are addresses. Starts with 7, like that. 8, 9, 10, 11.
Sir, these are the addresses?
Addresses.
Okay.
The address starts with 0 actually. Internally also 0.
Yes, sir.
12, 13. These are addresses. I'm just going with addresses. No one knows this one actually properly. So I'm giving the real example where we use local. Now,
Yes, sir.
let us suppose I'm creating a file x.c. I'm creating a file x.c.
Yes,
Okay.
sir.
So in this x.c, let us suppose we are using arrays to store your data. The internal hard disk is used in what? Arrays. Let us suppose to store your files. So these memories are already filled. Let me say the red color are already filled.
Yes, sir.
These memories are already filled. Now,
Yes.
now when I come to this x.java, since this is free space, wherever free space is there, it's going to allocate memory. So your x.java, let us suppose it's occupying this much memory. Your x.java is going with what? This memory.
Okay.
Okay. X.java has occupied how much memory? This one. The green color, whatever I'm showing here, is your x.java. So this is my x.java. Green color is my x.java. Sorry,
Yes.
x.c. X.c. Then after occupying this much memory, then after that I'm opening x.c file and I'm updating some more code.
So,
If I
sir, wait,
want to
sir.
try to,
Sorry, first I got it confused. So now x.c is the green and then what's red again?
the green is what? Your x.c language source code is stored here.
Yeah, and then
It is
what's
occupied.
red?
Red is like already occupied with some other piece
Oh,
of files.
got it, got it, got it. You can continue.
Some other piece of files means already occupied memory.
Because
Already
it's
occupied.
x.java, so I got confused for a second.
Yeah,
Okay.
x.c language. So C
Yeah,
language. So
understood.
x.c is occupied. So red colors are already what here?
Occupied from other things.
Occupied.
Yeah.
Red color is sorry, already used memory.
Yeah.
Used memory. Now, after that, if I try to update x.c file, do you have memory space after that? 11th space is already occupied.
Yes,
And
sir.
arrays are what? Sequence. Continuous memory only. Arrays will go for what? Continuous memory only. Since
Yes.
already 11 is occupied, what it will say? Memory not available.
Yes, sir.
It will say what? Memory not available. But if you
Yes,
see the diagram, is memory available for us here?
yes, sir. It's available for 12, 13, 14, 15,
So many
16.
memory spaces are there. So if I
Yeah.
use linked list concept to store files on your hard disk, what will happen? It is going to use this space. Let us suppose it's occupying this space for us. this space bar as, then what it will do, it will create a link here.
Oh,
When you
from
go
there.
for link list, it's going to create a link and says the address is what here? 17.
I see.
17. So from 10, it will jump to 17, the remaining piece of. So
Yeah.
wherever memory is there,
Or it
it is
will
going to write.
build,
So
or it will,
efficient usage of your memory is done with the
yeah.
linked list.
Or like, you know how you create a new one too sometimes in the middle, so it can also move 11 to 12 and then use 11,
Anywhere,
right?
anywhere it can be.
Yeah,
Anywhere
yeah,
it
yeah. Got it.
can. Okay, got it?
Yes, sir.
So to link the files, to store data of your source code of your file in different locations. So for that, to store files on your hard disk, it will make use of linked list concept in your operating system.
Okay, sir. Got it.
Clear? Then actual need of linked list. Then we are in
Yes.
something like stacks and queues. Stacks are what? When I go for stacks, of course you are not having syllabus about stacks. So when you go for stacks, whenever I'm writing some expression like x equal to 10 into 20, some expression if I'm writing, the internally these expressions are evaluated using stacks.
Okay, I
What
see.
are the expressions we are having? The expressions are evaluated using which concept? The stack concept.
Yes,
Queuing.
sir.
Queuing means queues. Queues are for what? Priorities.
Yes, sir.
Priorities. Like printer job, printing purpose.
Oh, I see.
Printing.
Okay.
So whenever I give printing, it will be in queue actually. So one after the other only it starts printing. So there we use, and where we use tree searching. When you are doing some searching, right? In your operating system, the internal code of searching is tree span.
Yes,
Clear?
sir.
So
Yes, sir.
data structures means maximum cases we use data structures to manipulate your operating system, to make
Got it.
your operating system work. That's the reason we say C and C++ is for what? System programming. And that system programming we do by using this data structures.
Okay, sir.
Clear?
Yes, sir.
Then clear about binary tree?
Yes, sir. On the
Right?
right side, it will have the right address. Left side, it will have the left address. It
Right.
has
Right.
two links, and then
So maximum they will ask you theoretical
yes,
question only for you.
have more
I have
children.
checked it. Yeah.
Okay.
I've checked your syllabus. They'll ask only theoretical question. So just you have to draw the diagrams like this. Explain
Okay.
it and draw the diagram. Okay.
Okay.
So programming, don't worry, maximum. Okay.
Okay. No problem, sir.
Even I'll write the code for binary tree and send it to you. So when time
Okay.
permits, you can go through that and you can
Okay.
learn it. Some
Thank.
because we should able to take care of the bad situations also. So I'll write the code of it. I'm not getting that code and not working properly. I'll write that code and send it to you. Then
Okay.
whenever you want to learn, you can learn it. It's very simple.
Thank you, sir.
Then we are in the very important one, tree traversals.
Okay, sir.
Tree traversals. What is this tree traversals? Accessing or visiting every element of the tree is called as traversal. I want to access every element. This is
Yes.
very, very important for you. They'll ask elaborate binary tree and the tree traversals.
Okay, sir.
Tree traversals. This is a major question they'll ask. We are in three types of traversals: pre-order traversal, in-order traversal, and post-order traversal.
Amazon. Yes, sir.
Pre-order means visit the root node,
Okay.
then after that visit the left node, then right. Pre means root, left, right. That's what you remember. Root will come first. Pre means
Yes.
what? Root will come first. Left
Yes.
after that left, right. In
Yeah.
means what? In between, in middle. Yeah, just concentrate on root only. Pre
Oh,
means first root, then left,
got,
right. In
got.
order means root will come in between. Left
Yes.
root, right. Post means root will be last.
Yes, sir.
So pre root will be first, in root will be middle, post root will be last. Then how
Last.
to
And
remember?
left
Left,
always.
right. That's it.
Got it, sir.
Think of root. Very easy to remember. Think of root.
Got it,
Pre
sir.
means root first, in means root middle, post means root right. That's an easy way to remember.
Yes, sir.
Right? See the diagram of this traversal. Here. We are having pre-order. What is pre? Root left to right. Okay. Then in order, left to root right. Post left to root right and root. See the diagram. Understand it. You have to elaborate this diagram compulsory. You have to draw the diagram and write the traverses. Same as it is. Even if you draw as it is the diagram, that's it.
Yes, sir.
So if I take a binary tree, like let me take the values.
So, sir, does it matter in what order you're doing? Like, you know, you did 18, 22, 12, 40. What if I did 12, 18, 22, 40? Does that matter?
No. Let me do one thing. Let me take the elements here. 20, 15, 40, then 22, 8, 6. I'm taking the same elements. 8,
Yeah.
6, then 12. It's 12, not 12. So let me go with my one. That diagram is wrong actually. 12 should not get connected to 22. It's wrong diagram. Okay. I have drawn like that. I don't remember. So let me start with 50. I'll write it once again for you. Everything. 50,
No
25,
problem.
45, 87, 56, 21, 76, 98, 10, 65. Some elements. Okay. This diagram is completely wrong. And I'll write the traversals for you. Here we are having the elements like this. Now, the first element is what? 50. Then 50 will become the root node here. 50 will become the root node. So 50 will be the root node. So first element, whatever we enter, that will be the root node.
Okay.
Next, 25. So when you are arranging, when you go for binary tree, always remember when you go for binary tree,
Yeah.
okay. So we arrange something like binary search tree concept. Binary search tree.
Okay.
Okay, I've explained that is right only, but which node you want to connect, that I've taken over. Okay, so binary
Yes.
search tree like this. When you go for binary search tree, if the element is less than root node, the diagram whatever I've drawn correct only. Okay, it's correct only. Okay.
Yeah.
So I was just taking binary tree only, but let me explain binary search tree now. If the
Okay.
element is less than root node, connect left. Connect left. Then,
Oh,
if the element is greater than root node, connect right. Let me even explain this with the diagram so that you can have all the idea. Connect right. Now,
okay.
so first node is what? 50.
Yes.
Okay. So here even we are discussing about binary search tree also. Binary search.
Yes.
So when you go for binary search tree, what is it? If the element is less than root, connect left.
Other if it's greater, it's left, right.
If the element is greater than root, connect right.
Yes.
Now first node, make it as the root node. 25. Is 25 less than root?
Yes. Sir. Oh, no, no.
Okay. 25 is less than root, right?
Oh, 25. Sorry, I was thinking something else. Yes,
25
sir.
is less than root, so we have to connect towards the left side. Connect
Yeah.
towards left side. Then next element 45. 45
So,
is less than 50.
Left. Yes, sir.
Yes. Then again comes to the left side. Again,
Yes.
45 is greater than 25.
45 is greater than 25, so it goes right
So,
then.
so right of 25. It will go to the right of 25.
Yes, sir.
Then next one. 87. 87 is greater than 50.
50.
So goes to the right side.
Yeah.
Goes to the right side. Then next one, 56. Again
56.
greater than 50. Again
Yeah.
87. 56 is less than
87. So it's
87.
close to
So
the.
56 will come this side.
Yeah.
Okay. Then, next one, 21. 21, where it goes?
Left side, sir. And then left
Left
again
side of,
after 25.
left side of 25. Okay.
Yes.
Left of 20.
Yeah.
Then 76.
76 goes right side of 56, I think.
Very good. They'll even give some numbers. They'll ask you to draw the diagram also.
Yes, sir.
Binary search tree. 98.
Right side of 87.
Right. Then 10.
Left side of 21.
65.
Left side of 56.
No. 65.
65. Oh, wait, no, it's greater than 56. So it goes right and then left side of 76.
Right. That's it. Got it? How to create binary search tree now?
Yes, sir.
Then once you create the binary search tree, you have to traverse it now. So when you go for pre-order traversal, pre means what? First root element. First root. What is the root element here?
50.
50. First root 50. Then goes towards the left. When you go
Yeah.
for left, again we are having subtree 25. Again
Yeah.
for 25, which is the left? 21.
Yeah.
Sorry, root. Sorry, 25. We have to visit the root. 25. Then after that, it will go to the left, 21.
Yes, sir.
After that, it will go to the left, 10.
Okay.
Then for 25, left is over. Right?
Yes, sir.
Now we have to come to right.
Oh, so now it will go to
Now come
40.
to the right.
So
Then
now when it goes
after
to
that,
the right, I'm guessing it will
50
go left
for
first.
50 left is over. Now come to the right. Again for right, 87 is the root. Then comes to the left, 56 is the root. For 56, there is no left, comes to right, 76. And for 76, left is again 65.
And then 90.
Right? Then again for 87, right is 90.
Yes, sir.
This is the way we get. Coming
Yes.
to in order. If you come to in order, first left means for 50, which is left, 25.
25.
Again
Yeah.
25 is the root. For 25, which is the left, 21.
20.
Again for 21, which is the left, 10. So for 21, left is over. Now root. Then for
So
21, do you have right?
21 we don't have right.
Right. Then for 25, left is over. Now root. Again right.
Yes, sir.
Then for 50, left is over. Now root. Then
So
come to right. Again, when you come to right, 87 is the root. So 8 for 87, left is 56.
56.
Then now for 56, left is not there. Comes to right. Again, right is for 76 is the root. Again for 76, left is 65. Then root. Then
Okay.
87 is the root. Then 98. Observe properly in order. Are you getting ascending order?
Yes, sir.
Right? So this is the way to sort the things using in order traverse. We arrange the elements as binary search tree, and when you traverse the elements in order, we get ascending order. And if you reverse this algorithm, means if element is less than root, connect right. If element
Oh,
greater
I have
than root, connect left. If you
this.
reverse it, then we get descending order.
Yes, sir.
We get this. Okay.
Yes, sir.
Coming to post order. Post order first left. first left. For
Yes.
50,
So
left is 25.
25
And
and
for
then
25, left is 21. Again after that 10.
10. Yeah.
For 25, 21, do you have right? No.
No,
So
sir. So you write 21, and then you write 45, then 25.
very good. 45, then 25.
Okay, and then I'm guessing you write 80.
Right.
No, wait. Then 87 is 56. Then
For
70.
56, we have left?
No, no, sir.
No. For 56, right is 76. For
Yes,
76, I think left is 65.
65. Yeah.
Then for 76, no right, then root.
Yeah, so
Then
76.
root.
Yeah.
Then for 87, left is over. Now right.
Right is
Then
90, then
root.
87, then 50.
And
Yeah.
finally,
Yes, sir. Understood.
got it?
Yes, sir.
Right? So these traversal are very, very important.
Yes, sir.
Okay. Right? So sometime like I'll write the code of this complete code. How
Okay.
to create binary search string and how to
Okay.
do the traversals. That also
Okay.
will help. I'll
Okay,
write
sir.
the code and send it to you. You can easily understand.
Okay, sir.
Okay. So if you are having background of linked list, understanding trees also very easy. Okay.
Yes, sir.
Then tomorrow what we do is tomorrow we go with the next one, searching and sorting.
Okay, sir.
Searching and sorting. The bubble
Sir,
sort is there that I need to discuss.
I just had one quick question regarding linked
Yeah.
list.
Yeah.
It's not even the question regarding linked list, regarding the code of linked list. If you could open
Okay.
it.
Linked list code.
Yeah, the code. Yeah. Down, sir. Down, down, down. So, sir, when you say like and uh, arrow link equals p, right? Yeah, I've noticed you use that to assign a lot of things.
Trace
Right? No, 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 not that. And
and
arrow.
link.
Yes, yes, and link equals p. Yeah.
Hmm.
So, sir, what exactly are you doing here? Like, what are you like? I know that you're allocating the memory of p to
See,
thing, right?
whenever you want to create a new node, a node is created.
Yeah,
This node is created.
yeah,
Let us suppose the address is some 100.
yeah,
The value is 10. So
yeah,
once you create a new node, this is my first node. How to
yeah.
know that this is my first node?
It
This
has
is
to.
now connected to what? P. P
Yeah,
is connected to this.
yeah,
Whenever you create new node, P is connected to this. Now, how to know that this is first node when your start is equal to null?
yeah.
Okay, if start equal to null, we are saying start and end equal to P.
That
So
part
now this address is now pointed by your start and end also,
yeah,
right? Start and end. Now, if I create, then after that, what you are doing? Once you create the node, immediately you are assigning to null also.
yeah,
So we are creating the new node and assigning P link to null. So node
yeah,
is created, and what we have to check whether this is our first node. How to know that this is our first node? When start is equal to null, this is my first node.
yeah.
Okay. So one node is created now. Now when I call the function create again it's going to allocate memory for us. So is it my second node now?
Yes, sir. So
So
now
by seeing the diagram, this is my second node. But how to check whether it is new node or existing node? Whether you are having already tree by checking here. If start equal to null, is start equal to null now?
no, sir.
No. So next time onwards, only first node, this piece of code will execute.
Yeah.
After that, it will come to only else part.
Yes,
So
sir.
when it
But
comes to else part, what is the
yeah,
value of end here?
the end value is right now it's 100, right?
100. 100 link. 100 link, you are making it what now? P. This is my P now. This link is breaking. This is
So
now P
you're
now.
so you're so you're assigning the link value to the address of p.
Yes, the new address, the new node, I'm giving to the previous node. The address of the new node, I'm giving to the previous node because I have to make a link now. Whenever I
Okay,
create a new node, I have to make a link between your previous node and new node. Got it?
okay, sir.
How to make a link? End link. What is the value of end? 100. 100 link, you are making it as P. What is P now? 200.
Okay, sir.
So the link will become now.
Okay.
Then which is the end node now? The new node what you have created, this will become the end node now. So what we have to do, whenever you create a new node, we have to give that address to the previous node and make the new node as end node.
Yes, sir. Got it.
Okay. So the previous link, I should make it as the new link and make your new node as end node.
Got it.
Again, if I create one more new node, again it's going to allocate memory for me.
Yes, yes. No, understand all that.
Okay.
I understand the algorithm behind it, sir. I just, I think I need to go over structure pointers because I'm having a little hard time wrapping my head around the actual syntax of the code.
Right, right.
Yeah.
So now P is pointing to 300. Now what I should do? Now, before I make this 300 as end node, I have to make a link first. Don't write end equal to P first. No, wrong. First we have to make a link between your previous node and new node. So
Yes.
P end link. What is end? 200. 200 link. You are making it as 300.
Yes, sir.
Then
So
you are
I'm
making this
assigning
P as
the
what? End node.
address of
You are making
P
P
to
as
the link of end.
end.
Okay, I
End.
got it. Got it, sir.
Okay. Right? You have to draw the diagrams and understand. Okay. See the code. Draw the diagrams. When you draw
Okay.
the diagrams, this is very, very easy for you.
Yes, sir.
Right?
Yes, sir.
Okay. So tomorrow, what concepts we have to discuss? Tomorrow I'll be discussing the last part. Like we'll be discussing searching, sorting, and matrix multiplication.
Okay, sir. And that's the
Okay.
last class tomorrow?
Tomorrow is the last. Same time, 8 o'clock you can join.
Okay, sir.
And within 1 week, I'll send the program of results. I'll send the program. I'll create it and send it.
Okay, sir. Thank you
Okay.
so much.
Thank you very much. And if I miss something, put a mail to me. Okay. I'll
Okay,
write the things for you.
okay, sir.
Thank you very much.
Okay, thank you, sir. Have a good day.